Have a look at an example of doing a tidal stream, and we're told that a tug and tow are due to transit through Seymour Narrows, British Columbia, 0700 on the 3rd of January. The maximum speed of the tow is 9 knots and will be steering a course of 180. Determine the speed of the vessel over the ground at 0700 hours. So we need to go into the tables and look for Seymour Narrows, and we can see the direction there is 180 degrees 00, so positive negative. We go to the day, January the 3rd, and we can see it's written slack and maximum and the rate. So we can write maximum 13.2, slack 510, maximum 815, minus 10.3. So we write all these values down that are indicated there. And as you can see, I've written them all down and written positive 180, negative 0. Then we can plot. So what I've had to do on this one here, of course, is change, or when I say change, put the values here, 3, 6, 9, 12, 15, 3, 6, 9, 12, 15, and 130 it was 13.2, so that's 0 hours, 1 hours, 130, 13.2, 510, slack, 815, minus 10.3, and so forth. So plot all the values and then draw a curve. Don't draw it as a straight line, draw it as a curve. And then we're asked to determine the speed over the ground at 0700 hours. So we find 700 hours, which is here, go across, and we can see that the speed is 6 knots. Okay, so 0700 hours, 6 knots, and the direction, of course, is 0. So our vessel's speed has to be 9 minus 6, 3 knots. So the speed of the vessel is 3 knots. Of course, our course is 180, so we're actually directly opposing the rate. That's why our speed drops to 3 knots. So they're quite straightforward. Write the values down. It's a very standard curve, very standard graph that you use, and just put all the values on, but make sure you draw it as a curve.